Hello gentlemen, this is the last video for week 2. We're going to talk about rational inequalities. A little bit similar to what we did with polynomial inequalities, but just a couple things that we need to look at that are different in terms of critical numbers. And then we'll do a couple examples and we'll wrap it up for the week. Alright, let's get started. When we're talking about a rational inequality, we want to write the inequality with the rational expression on the left and 0 on the right. Okay, so we want to do the whole expression. We want to manipulate that expression so we have 0 on the right-hand side of that equation, okay, or the right-hand side of that inequality. We still need to find critical numbers. Now the critical numbers are a little bit different than what we've done in the past. We want to look at the zeros, which is where the numerator is going to be equal to 0. And we also want to look at the undefined values, and that's where the denominator is equal to 0. Okay, and if you remember when we're talking about rational expressions, let me get my pen out here. We had a function f of x in the form where we had a numerator and a denominator function. Okay, and so our critical values are when we have the zeros, which is when the numerator is equal to 0, and then we had the situation where the denominator are those undefined values. Okay, so that's what we're going to look at for our critical values. We're going to do exactly the same thing as we did with polynomial inequalities. We want to set up our test intervals. Once we set up our test intervals, we want to choose one x value in each interval and evaluate the expression and see if the inequality is true or false. Once we do that for one value in each interval, we know it's going to be true for the entire interval. Okay, just like we did before. The main difference that we have here is the critical numbers. We have to find out where we have those undefined values, which is where the denominator is equal to 0. Let's do a couple examples. Solve this inequality. All right, and so this one's actually set up pretty nicely for us. We have the expression on the left and we have 0 on the right of the left-hand sign. What we would want to do here is we certainly want to get a common denominator, which is just x. And so you should see that this is 1 minus 4x over x. These are equivalent. Next step is to find the critical numbers, and that's when the numerator is going to be equal to 0. And so I'm going to have 1 minus 4x is equal to 0, or 4x is equal to 1, and so x is going to be equal to 1 over 4th, or 1/4. And then when the denominator is 0, is obviously going to be x equals 0. So we have two critical values here, x equals 0 and x equals 1/4. That's going to allow me to set up my test intervals. Okay, and now the next step is to pick some values. So over here I'm going to pick -1. Okay, and then what I'm going to note when I pick -1 and I plug it in to this expression right here, the numerator is going to be equal to 5, and so I will get over here, I'll get 5 over -1, which is equal to -5, which is obviously less than 0. So it's going to be true on this test interval right there. If I pick an eighth, if I plug in an eighth here, I'm going to get 1 minus 4 times an eighth, which is going to be a half, and that's going to be over an eighth, like that. This is going to be 1 minus 1/2 over an eighth, and we should see that that is actually greater than 0, so it's not going to be true in that interval right there. And then if I take a point out here, choose 1, 1 would be very easy to choose. You should see that I'm going to get 1 minus 4 over 1, which is less than 0. So I'm going to be true out here, I'm going to be true over here, but not in the middle. Again, this is just a less than, there's no equal sign, so we do not want those endpoints there, or those intervals. And that's why we're going to have those open brackets right there and right there. Okay, if we write this in interval notation, let me get rid of some of this. This is your solution in interval notation right there. Okay, and note here that I have open brackets. I have open brackets on both sides. Means I'm not including 0 and I'm not including 1/4. Do another one. This one's a little bit more complicated. Again, I want to rewrite this expression to get the entire rational expression on the left-hand side. So I bring that negative, I bring 3 over x plus 2 to the other side. Next step that I want to do is I want to get a common denominator. I want to get one expression. And you should see that the common denominator here is x minus 6 and x times x plus 2. So if I do a little bit of math here, I multiply the first term by x plus 2 over x plus 2, and the second x minus 6 over x minus 6. I'm not changing the value here. That simplifies down 5x plus 10 minus 3x plus 18 all over x minus 6x plus 2. All right, and let's do one more step of simplifying right here. Okay, so once I find my common denominator, now I have my rational expression on this side, on the left-hand side, and I got 0 on the right-hand side on my inequality. Next step, find critical numbers. So obviously when I set the numerator equal to 0, you should see that x is equal to negative 14. So that's one critical value. And then I look when this is undefined, or when the denominator is equal to 0. So in that situation, x would be equal to 6, or x would be equal to negative 2. So I have 3 critical numbers right there. And now I want to set up my test intervals like that. Now again, I gotta pick points in these different intervals here. So if I pick a point out here, say negative 15, and I want to see what happens out there. The top here, let's just look at the sign because that's what we're primarily looking at. On this interval here, the numerator is going to be negative because I'm going to have negative 15 plus 14, obviously negative 1. The first term on the bottom is going to be negative, and the second term on the bottom will be negative. So 2 of these negatives will cancel out, but I'll still have another one. So this is actually not going to be true here because this is going to give me a negative value. Okay, so this is less than 0, so this isn't going to be part of our solution set. Let's look at the next interval. Let's plug negative 10 in there. Again, if I look at the signs here, what's going on with the signs, the numerator will be positive. The denominator, the first term of the denominator will be negative, as will the second term. These negatives will become positive. I got a positive value here. So this part is going to be true. This is going to produce a value that is greater than 0. Let's look between negative 2 and 6. Obvious answer there, choice is 0. Again, if we look and see what's going on, top is numerator is positive. This term, first term, is negative. This one's positive. So this is actually going to produce a value that is less than 0. Okay. And then we need to choose one out here. Let's say 10. If I choose one out there, again, the numerator is going to be positive. The first term in the denominator will be positive, as will the second. So this will also be true. Okay. Let me erase some of that for you. So now we have to draw conclusions here. You know, what do we have for result? Well, we should see that we're true in this area right here and then out here. And let's see how I graph that solution set, and there it is. Okay? Again, I got all open brackets because it's just greater than 0 right here. All right? If there was an equal sign, then we would be looking at some different values. Okay, again, we would always have an open bracket at 6 and negative 2 because that's when these are 0 in the denominator. We obviously can't have that. Okay? Let's do a word problem. I've given a revenue function. I'm given a cost function. I want to know how many units I need to sell to obtain a profit of at least $750,000. And then if I get that, what is the price per unit? Okay, so let's first start about talking about what is the profit. What's the profit function? Well, profit is going to be your revenue minus your cost. Okay, what am I bringing in minus my cost? And so I combine these two functions and I get a profit function right here, and I can obviously simplify that down to this stage right here. Okay, now There's my profit function, and now what do I want to do? I want that to be greater than or equal to $750,000. So now I can set up my inequality. Okay. Again, I want to get all the terms on one side, and so I'm just going to rewrite that. I'm going to bring this term over here, and I want this now to be greater than or equal to 0. There should be an equal sign right there. Okay? So I need to find my critical numbers. All right, it's not as obvious as we would hope, but it's a quadratic formula. And so a quadratic function. So I can use the quadratic formula to find my critical numbers. If I do that, I get two critical numbers. X is equal to 40,000 and x is equal to 50,000. So now I know I can set up my test intervals like that. And I want to pick some values in here and test on that interval. Okay, again, looking at my calculator would be really helpful here. I would note that this is less than 0. So in other words, I'm not making a profit of over $750,000 on this interval over here. Okay. In this interval between 40,000 and 50,000, I am greater than 0. So this is the region here where I'm making that profit bigger than 750,000. Again, plug in a value 45,000. Look at a graph, which would be really helpful, especially using the TI-84. And then if I go beyond 50,000 from producing more than 50,000, I can see that this is going to be less than 0. And therefore, again, I'm not going to have the profit that I'm looking for. Therefore, I'm going to conclude if I want to have a profit of at least $750,000, I have to produce between 40,000 and 50,000 units. Okay. If I want to look at the price per unit, that's going to be the revenue function over X, over number produced. Going back to the couple slides ago where the revenue function was right here. If I divide out by X, it simplifies down here. I know what my X values are. They're between $40,000 and $50,000. So I can plug in $40,000. I get 55 as my unit price. I can plug in 50,000. I get a unit price of 50. So what that's telling me is that in order to make a profit of $750,000, the price per unit will be between $50 and $55. Okay? Hopefully that makes sense. I would, in a problem on a test or a take-home, give you the information that profit equals revenue minus cost, and I'd also give you the price per unit equation. Okay, but you would have to know how to use it to find the correct answer. All right. Read these pages, fellows, 201 to 203. Again, looking at these examples. Examples are really good and really helpful. A few more problems here to solve as practice, and then I would tell you to make sure that you're getting started on your problem set that's due on Monday. Any questions, you need to make sure you email me. Again, the purpose of this video was rational inequalities. Basically what we wanted to do was get everything on one side, get the rational function on one side, and 0 on the other side of the inequality, on the right-hand side of the inequality. From there, we wanted to find our critical numbers. Again, for rational expressions, rational functions, we wanted to find out when the numerator was equal to 0 and where the denominator was equal to 0. Okay, and where the function was undefined. From there, we were able to set up our test intervals, and just like we did with polynomial inequalities, we would test values in each one and each interval to determine where the inequality was true and where it was false. Okay. Practice this stuff, fellas. Hopefully this was a good week for you. Again, questions, email me. Okay? Have a nice day.